Welcome friends. So now today we are going to discuss a second problem on array, which is find maximum water which can be trapped within a histogram. So let's assume that you are given a histogram of like every bar is of width 1 and height 1. So now let's say if you pour water into this histogram where where you can save the water. So one unit is here, I'll say this is where the water will come. Second somewhere here, right? So it will be within this one, so you will be able to save water here, and I think nowhere else. So total how many unit of water you saved? I'll say this is 1, this was 1, at this bar it's 1 and 1, here it's 1, here one more, here 1, and here it's 2. So total 1 2 3 4 5 6 7 8. So total your answer should be 8. So 8 unit of water you are able to save. So now how to solve this? Here I'll suggest you to pause the video and think how can we solve it, and then we'll jump into the solution. So pause the video. Okay, so now you have already given a thought on how we are going to solve it. So let's discuss the solution. So at this, how much water I can save? It's visible, it's nothing. Second, how much water we can save at this position? It's actually like you need a containment zone where you will be storing the water, right? So you have to find the max. On the left, the max bar on the left, and the max bar on the right. So in this case, the max bar on the right is actually this one, right? And the max on the left is this one. And you won't be able to store water here, right? Because water will flow out of this bar. So the minimum out of these two bar, like these two bar, is your answer. So here it's 1. So at this you will be able to store this into the minimum of the highest bar on left and right, so which is 1. So in this case you are going to store 1 unit of water, right? Now we move here. You have to find the maximum on the left and the maximum on the right. In this case there is no max on the left, so the answer will be 0. You have to go to the next index where you will see that the max bar on the left is this and the max bar on the right is this, and the minimum of these two is 2. So you'll be able to store 2 into the width of this, so you'll be able to store 2 unit of water. Similarly, in this scenario you'll be able to store 2 unit of water. And then here the left max is this and the right max is this, so you'll be able to store the minimum is 2. So and you have to reduce this width as well, so you have, that will be like 2 minus 1 unit, so which is 1. Here it's 2 minus 0, which is 2. So your answer is 1 plus 2 plus 2 plus 1 plus 2, which is 8. So this is how we solve it. So this was the basic approach, right? How did we do is like for every element we go and find the max on the left, we go and find the max on the right, and then we calculate how much water you need to store. But now just imagine if you can have it in advance. So let me explain it to you. Okay, so let's discuss the second approach. How are we going to do this? Is when we were doing it for the first time, what we were doing is when we were going and iterating over each element, we were again going back in the first half of the array and the second half of the array to find the left max and to find the right max, right? So what if we can store these two values in advance instead of while iterating and then doing it again and again for each element? We can always store these values in advance. So how are we gonna do it is we prepare a left max and we prepare a right max array. So this will be a new array, and how are we going to do it is we find the left max. So for every element, what's the maximum on the left? So in this case the maximum on the left is 1, right? In this case, the maximum on the left is 1. In this case, the maximum on the left is 2. In this case, it is 2. In this case, it is 2. In this case, it is 2. In this case also it's 2. In this case, it's 3. While doing for the right one, we have to start from the right. So what is the maximum on the right in this case? It's 3. For this element, what's the maximum on the right? It's 3. I think 3 for all. So for every element, the maximum on the right is 3. Now what we do is we go, so now we start iterating over the array, the original array. And now for each element, we find the minimum out of these two, right? So minimum is 1. So 1 minus the current element 1, so which is 0. So at the first element, I'm going to be able to store 0 unit of water. In the second element, what's the minimum out of these two, which is 1. My current element is 0, so I'll be able to store 1 unit of water. Similarly, if you do here, the minimum is 2, the current element is 2, so the answer will be 0. In this case, if you do 2 and 3, minimum is 2, current element is 0, you will be able to store 2 unit of water. In this particular, it's again the same. 2 is the minimum, current element is 0, you will be able to store 2 unit of water. In this case, minimum on the left is 2, maximum on the left is 2, and maximum on the right is 3, and the minimum out of these two is 2. Current element is 1, so I'll be able to store 1 unit of water. Similarly, in the last, it will be 2 minus 0, which is 2. So total it gives you 8, right? 2, 2, 2, 1 and 1, so 8. So this is how we are going to do it. So now let's jump to the code part of it. Also, let's discuss the time complexity of both the approach. So in the first approach, what we did is we were iterating over each element, and for each element we go and find the maximum on the left and maximum on the right. So it's also n. So time complexity was O n square and space complexity was O1. But in the second approach, what we were doing is we first prepare the left max on the right max array, right? So the space complexity is O(n), and the time complexity is we just iterate over the first input array and we prepare the result, right? So time complexity is also O(n). So yeah, now I think we can start working on the code, and let's see how does it look. First, I have already written the functions in the test. So if I go and run the test for these two, which I have already written, and the benchmark as well, both the test case failed, the original way and the optimized way. So both the test case failed. So now let's go and quickly write the code for it. So the normal way is we go loop over the elements, and then for each element we go and find the max, right? So let's loop over the elements. So my left is my current element, and then for each element from 0 to I, I'm going to find if there is a maximum, then left. So I have prepared the left, and now I also have to find the right? So now I have the right and the left and the right ready. So now we just have to calculate the total water saved. So my total water will be, so this is what we did, right? So the minimum of left max and the right max minus the current bar, and just keep on adding to the result. So we just go and return the result. So I think we are ready with this test case. So let's just quickly run the first test case. So in this, if the bar is 3024, your total answer should be 7, right? So all both of the test case passed. So now let's go back to the optimized one where time complexity is 1 and the space is O(n). So you have to prepare two arrays of left max and right max. Okay. What is length? Length is your length of bars. Now what else? So how will you prepare it is, first your left max 0 will have the bars 0, and now you have to prepare the full array. So whichever is the max, the left max for the previous element or the current element, whichever is max, that's your left max, right? Similarly for right, if we have to do, will be a little different. We have to loop from the n. Now for the right, what we do is, so I have the right max also ready. Now what we have to do is just loop and calculate the result. So result will be again the same thing what we did in up. The minimum of left and right max and minus the current bar. So I think second is also ready. Let's quickly run the test result. Okay, it's the same test case which passed. So now let's run the benchmark for both of them. So go bench and let's see how does it perform. Okay, I have the result. So for benchmark, I used a very big input, not very big, but yeah, quite big. So you can see the difference. So this was 873 nanosecond per operation, and this is 766. And memory, this has a little more footprint than the normal way. So yeah, I think yeah, I'm done. So if you have a better approach to solve the same, please put a comment in the video. See you soon until my next video. Bye bye.